Welcome to True Project. In this video, we are going to explain about a project titled MSFYOLO Feature Fusion Based Detection for Small Objects. So now coming to the introduction part. MSFYOLO is a cutting-edge object detection framework that specializes in the detection of small objects within images. Its feature fusion-based approach, combined with the efficiency and accuracy of the YOLO architecture, makes it a valuable tool for a wide range of applications where the identification of small objects is of paramount importance. MSFYOLO builds upon the YOLO foundation by introducing novel techniques to enhance the detection of small objects. So now coming to the objective part for this project is to advance object detection technology within a specific focus on the detection of small objects. By implementing feature fusion techniques and maintaining real-time capabilities, it seeks to provide more accurate and reliable results in a wide range of applications where the identification of small objects is critical for decision-making and automation. First, here we have improved small object detection. MSFYOLO aims to significantly improve the detection performance for objects that are small in size or have limited spatial information. Second, we have feature fusion. The core objective is to leverage feature fusion techniques effectively. And third one is the real-time performance. While focusing on small object detection, MSFYOLO strives to maintain real-time capabilities, ensuring that it can process images or video streams quickly and efficiently, making it suitable for applications that requires timely responses. So now coming to the requirements part, here we have two types of requirements: hardware requirements and the software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of work, here first we have importing the packages. This step involves importing necessary software libraries or packages in a programming environment. It is crucial to bring in the tools and functions needed for subsequent tasks. Second, here we have exploring the dataset. Beat detection data RoboFlow. This dataset likely refers to a collection of data related to beat detection. Exploring it involves examining the dataset's structure, contents, and metadata, which is essential for understanding the data you are working with. In this, we include beat detection data RoboFlow. This suggests another dataset specifically focusing on annotations for beat detection. Exploring this dataset typically means inspecting the annotations provided for each image to understand how objects of interest are marked. Second, it includes beat detection notation base. We have already discussed about this. And third, here we have image processing, appending the image annotation file and images. So in this, we include combining image files with the corresponding annotation files, linking the visual data with the annotations for object detection tasks. Second, here we have converting BGR to RGB. This step involves converting the color format of images from BGR, that is blue, green, red, to RGB, that is red, green, blue. This is important as some image libraries and models use RGB while others use BGR. Third, here we have creating the mask. In the context of object detection, a mask typically refers to a binary image that highlights the region of interest. Example, the location of beat objects. Creating masks is crucial for training and evaluating object detection algorithms. Next, here we have resizing the image. Resizing the images to a specific resolution or aspect ratio is often done for standardization as well as to match the requirements of the chosen object detection model or framework. It helps ensure uniformity in input data. Next, here we have data augmentation. In this, we have randoming the image. Introducing randomness into the images, which may include changes in brightness, contrast, or other visual characteristics. This includes diversify the training data. Next, here we have rotating the image. Applying rotations to the image at various angles, rotation augmentation helps the model generalize better to objects in different orientations. Next, here we have transforming the image. Transformations like scaling, shearing, or flipping the images to create variations in the dataset. This enhances the model's ability to handle different object shapes and positions. Next, it includes data extraction and splitting the data. This step involves extracting relevant information or features from the dataset and splitting it into subsets for training, validation, and testing. It is crucial for building and evaluating machine learning models effectively. Next, here we have installing the packages required for YOLO V5 in Colab. In a Colab environment, that is Google Collaboratory, a cloud-based Python notebook service, this step involves installing the necessary software packages and dependencies required to run the YOLO V5 model. This ensures that the model can be executed within the Colab environment. And the next one, here we have processing the data based on YOLO V5 model. This step involves preparing the data in a format suitable for training within the YOLO V5 model. Next, here we have building the model in Colab. It includes YOLO V5. constructing the YOLO V5 model architecture in a collab environment. It is a popular real-time object detection framework. Then we have YOLO V6, similar to YOLO V5, building the YOLO V6 model in collab. This may refer to an updated version or variant of the YOLO V6 architecture. Next here we have faster RCNN, building the faster RCNN, that is region-based convolutional neural network model in collab. This is another object detection. Next here we have training the model, the process of teaching a machine learning model, that is YOLO V5, YOLO V6, faster RCNN using labeled data. Next we have building the model with YOLO V5. Specifically, creating the YOLO V5 model architecture in your chosen environment. YOLO V5 is known for its speed and accuracy in object detection tasks. Next, we have Flask framework with SQLite for sign up and sign in, using the Flask web framework in combination with SQLite, a lightweight relational database. Next, we have user gives input as image or video, allowing users to input either images or videos to the system. This input serves as a source for license plate detection. Next, we have the given input pre-processed and with trained model is used for detecting the license plate. Pre-processing involves preparing the user-provided image or video for analysis. Next, we have the segmented each object input bounding box. After license plate detection, the system segments or isolates each detected license plate. And the last one here we have final outcome is displayed, presenting the results to the user as a final outcome. Typically, this would include showing the original image or video with bounding boxes around the detected license plates, providing a clear visual representation of the system's findings. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as dataset V5 and dataset V6. In this we are containing some dataset over here which is used in this project. Next folder which is named as sample. This folder is containing some sample images over here, and the folder named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files, and the folder named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML pages. Next here we have sample submission and train. These two are the .csv files which are the dataset which is used in this project. And next here we have this file which is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. Next here we have signup.db file which appears to be the database file which used to store the information over here. So now just copy the path from here, open the Anaconda prompt, type cd command followed by a space, and now just paste the path over here. Now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. Here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. So here I am using Chrome. Just paste the link over here and now hit the enter button. So here you can see that this is the home page about the small object detection, that is MSFYOLO Feature Fusion based detection for small objects. Now simply click on sign up button. Here this is the registration form. Simply enter your username, full name, email, mobile and password and click on register button. Here I have already done the sign up, so I am clicking on sign in button. Just enter the username and the password over here which you have created while doing the registration over there. And now click on login button. So here you can see that it is asking for uploading any image. To click on choose file, upload this image and click on open button. And now click on upload button. So you can see it is detected the normal beat plan is 0.80 and Diksha for 0.33. Click on back button and now click on about button. So here you can see about the YOLO V5 object detection and satellite images object detection over here. So by clicking on the sign out button, you can simply log out with this. So now coming back to the conclusion part. In a rapidly evolving technological landscape, MSFYOLO stands as a testament to the continuous advancements in the computer vision and deep learning, demonstrating the potential to significantly impact industries and improving the safety, efficiency and accuracy of various applications reliant on small object detection. As extension, we applied YOLO V5 and YOLO V6 for analysis, the dataset, in which YOLO V5 model got 99% score in detection. So YOLO V5 is used for building the model and it is used for detection user input in the front end. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.